I noticed that the geometry book that I was looking in does not use the expression Sohcahtoa. Have you had any trig at all? Did you get any trig in Algebra 1?
No, this was just a sheet that they gave me as I walked out the door.
Today?
So this is my first experience with it.
Okay, cool. Then let me teach you it my way. Trig starts with this. Memorize that. Pronounce it however you want. I pronounce it Sohcahtoa, like you're going to soak your big toes. Sohcahtoa. And what it means is that your three primary trig functions are sine, cosine, and tangent. Okay? And what the SOH means is that the sine is the opposite over the hypotenuse. There's a little over in each of these. And the O does not stand for the over. The O always stands for the opposite. So really, sine is opposite over hypotenuse. So if you're looking at that picture right there, and you're always taking trig functions of angles, very important distinction. You take trig functions of angles in order to get ratios. So if I'm looking at this triangle on the left, the sine of theta, whatever theta is, I don't even know what it is, but it's some angle, is the opposite, 5 over the hypotenuse, 13. So I could say the sine of theta is 5 over 13. Cosine of theta is the adjacent side over the hypotenuse. Now, whenever you look at any angle, there's two adjacent sides to every angle, right?
Yeah.
In other words, if I'm looking at theta, 12 is an adjacent side, and so is 13. Well, when they refer to the A up here, they're always referring to the adjacent side that is not the hypotenuse. So cosine would be adjacent over hypotenuse. Well, the adjacent has to be 12. Hypotenuse is 13. And finally, the tangent of theta is the opposite over the adjacent. So what would the tangent of theta be with this triangle on the left?
The 1 over 2?
No, the one on the left, not this triangle here, but this. We'll get to this triangle in a minute.
Sorry.
But this triangle here,
5 over 13?
It's 5 over 12.
Okay.
You see why? It's not over the hypotenuse, it's over the adjacent. So it's these two letters that are key. Sine is opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. And
okay, so what's the second acronym again? Sorry, let me write it down.
Ka. Sohcahtoa.
Okay.
And it's important to pronounce that ka instead of ko. In other words, it's not Sohcahtoa, because if you pronounced it like that, you might stick an O in there. In other words, it's got to be S-O-H, C-A-H, and T-O-A. So however you can memorize that, do it. But memorization, they tell you to think of graphic images when you're trying to memorize something. Well, when I was a kid, my big brother had an infected toenail, and he had to soak it for like a week. That was the cure for it. So the way I remember this is Sohcahtoa. Sohcahtoa. But however you have to memorize it, memorize it. It's definitely the very first thing in trig that you're going to have to memorize. Now, trig is like a foreign language. You probably have never heard these terms, or not very often, sine, cosine, and tangent. So it really is, you're going to be dealing with a whole new vocabulary. And it all starts with that. If you can't memorize that, you cannot make any progress at all through trig. Okay. Now, notice that I'm always taking trig functions of angles, and I didn't know what that angle was. Didn't really care. Whatever that angle is, the sine of it is 5 over 13.
All right.
Now, let's look at the triangle we're a little bit more familiar with, this one over here, where we have all three sides dimensioned, and we know all three angles. So, if I said to you, what is the sine of 30 degrees, what would that be equal to?
1 over 2.
1/2, exactly. 1 over 2. Now, notice something. That instead of having this be my unit special triangle, I could make it bigger. Let's make it bigger. So all I did was multiply each side by 10. Okay? Now what's the sine of 30 degrees?
Of 30, it would be 10 over 20.
Still
1/2. Or still 1/2, I guess.
So it matters not what these sides are. The sine of 30 degrees is always 1/2. What kind of calculator do you have, Mark?
I have one of the fancy ones, TI Inspire.
The new ones? Okay.
Yeah.
Well, I have a virtual TI-84. Have you ever seen these?
I think so.
Okay.
Yeah.
Well, I don't have a virtual Inspire. I wish I did. Those are too cool. I have an Inspire. But on the TI-84s, and in fact all calculators prior to the Inspire, there's only 3 trig functions: sine, cosine, tangent. Notice that if I hit sine, and then I hit 30 for degrees, gives me 0.5.
Okay.
So trig functions of angles are constants. The cosine of 30 degrees is always square root of 3 over 2, which is that number. And it doesn't matter the triangle. In other words, these things are constants. When I was back in high school, and we didn't have calculators, all of the math books had tables in the back. And they had tables for sine, cosine, and tangent for every degree. For 1 degree, 2 degrees, 3 degrees, and so forth, up to 90 degrees. And so you had to look it up in a book to find out what these values are. Now, the common ones, like 30 degrees and 60 degrees, well, I can get those from my picture here. Obviously, sine of 30 is 1/2. Cosine of 30 is what?
Cosine of 30 would be 2 over square root of 3.
The other way around. Remember, the hypotenuse is always the bottom. So it's square root of 3 over 2. In other words, it's this
Cos
over that value. The adjacent.
Wait, so cos stands for cosine adjacent over hypotenuse?
Yes.
Okay.
Exactly. And
these are only for angles, right?
these are only for angles. You only take trig functions of angles. And what would the tangent of 60 degrees be?
That would be
Opposite?
2 over 1?
No. Start with the angle. In other words, start up there.
Okay.
What's the opposite side?
Okay. Square root 3.
And what's the adjacent side?
2.
That's one of the adjacent sides. But remember that when we are referring to this A up here, we're always referring to the adjacent side that is not the hypotenuse. So the adjacent.
Okay, that makes sense.
Okay. In other words, the adjacent side referred to in Sohcahtoa is never the hypotenuse. If you're referring to the hypotenuse, you need H. That means opposite, that means hypotenuse, that means the adjacent side that is not the hypotenuse. And you're always taking these trig functions, well, for now, of acute angles. In other words, we don't take the trig function at 90 degrees. We do eventually. When you get into trig, you'll realize that you can take trig functions of angles all the way up to 360 degrees. In fact, any angle you want has a trig function value. But in geometry, they kind of limit you to right triangle trig. And it's worth noting something, that we are only talking about right triangles when I talk about this. In other words, there is no hypotenuse if it isn't a right triangle. So this does not work for non-right triangles. If I draw a triangle like this, maybe 6, 7, 8, and I say, what is the sine of theta? I don't know. I can't answer that. Not yet. We'll be able to once you get further into trig, but that won't happen for a couple years. You'll get a little bit more trig next year. You'll actually get quite a bit in Algebra 2. And even probably a lot of this more advanced trig. But what it most definitely is not is 6 over 7 or 6 over 8. Okay? In other words, we can only use that definition for sine, cosine, and tangent if we have a right triangle. So, let's just practice a few more. Let's see, if that's 1 square root of 7, 4 doesn't work. I got to put the square root of 7 down there. Now 1 squared plus 7 is 8. Square root of 8 is not 4. Square root of 8 is 2 root 2. So now, does that work? Is that a right triangle? First of all, tell me, it actually, they haven't really, you've done the Pythagorean Theorem. That's what you worked on last week. So, if I gave you this triangle, could you tell me whether that is a right triangle or not? What has to be true for this to be a right triangle?
It has to have a 90-degree angle.
Well, more importantly than that, it has to fit the Pythagorean Theorem. In other words, 1 squared plus square root of 7 squared has to equal 2 root 2 squared. And if that is true, then this is a right angle. Well, what is this? 1 plus 7 equals 4 times 2, 8. So by virtue of the fact that this side squared plus this side squared equals this side squared makes that a right angle. Okay, so
Yeah.
now let's look at some trig functions. And the only way you're going to learn these is to drill them. In other words, it's just, you can't memorize something like the definition of sine, cosine, and tangent without practicing. So I'm just going to go through some. And like I said, I don't know what these angles are, so I will just label that theta. You could also label it x. In fact, let's label it x. You don't have to label angles with Greek letters. You can label them like that.
Oh, yeah.
So now tell me what the sine of x is.
Okay. So that'd be sine opposite over hypotenuse.
Okay, so give me the numbers.
Square root of 7 over 2 square root 2.
Hold on. Opposite always is the side. If you look at your angle, that angle is made up of two lines, right?
Yeah, yeah.
This one here and this one here. Well, the side connects those two lines, which is this one here, is opposite to angle x. Okay, so even on, here, let's just take a particularly different one. I call this A, B, C. What's opposite theta?
A.
What line is opposite angle theta? It's, in other words, we're not looking for an angle that's opposite it. I can see why you said A, but what we want is the side that is opposite that angle. Is it AB, AC, or BC?
AC.
No. Take the two lines that make up that angle, that one and that one. Where do they end?
Okay.
Right here and here. And what connects those 2 points? AB.
Okay.
So AB is opposite theta. AC is opposite angle B. And BC is opposite angle A.
Okay.
Okay? So that's the way to figure opposites. In a more traditional triangle, like an acute triangle, it's not as hard. It's a little bit tricky when you get an obtuse triangle like this. In other words, it's not as clear what the opposites are, but that's how you do it. You just take the angle, the two lines that make it up, whatever line connects those two lines, that's opposite that angle. So what's the sine of x? And just do these, don't try to do the whole thing at once, just do what's the opposite, and then what's the hypotenuse, and put one over the other.
1 over 2 square root 2.
Okay. Now, we don't want a decimal answer, despite the fact that if I went into my calculator and said what the sine of an angle is, it's going to give me a decimal answer. It doesn't give me the radical answer. This is a radical answer. Totally precise. But there's no way I'm substituting 1.41 for square root of 2 and coming up with a decimal. I'm just not going to do it unless I absolutely have to. So there is a problem with this answer. What is it?
For which one?
This answer right here.
Cosine?
In other words, that's no. For the sine of x, we came up with 1 over 2 root 2. But there's something
Okay.
wrong with that
Yeah.
answer. What is wrong with this answer? It's the right number.
Oh, you can't have a
There you
you
go.
can't have a square root in the bottom denominator.
You cannot have an irrational denominator. So we have to rationalize.
Okay.
We have to rationalize that answer. What do I do to rationalize it?
Multiply by the square root of 2.
Well, I can't just multiply by the square root of 2 because that changes the value. But
Okay. So divide by them.
well, I can multiply the bottom by square root of 2 and then the top by square root of 2, because now all I'm doing is multiplying that fraction by the number 1. You can multiply any fraction by the number 1 without changing its value, no matter what it is. You cannot multiply it by any other number. If I multiply it by any other number other than 1, I'm going to change its value. Well, when I do this multiplication, I get square root of 2 in the top, which is perfectly fine. And in the bottom, I get, what's 2 times square root of 2 times square root of 2?
2 square root 4.
Simplify it.
4.
Okay. That's what you get. So that is a proper answer to this question. Okay?
All right.
And since trig, right triangles have tons of radical signs. I would say most of your right triangles are going to have a radical sign in it. You don't get very many right triangles that are 3, 4, 5 or 5, 12, 13. They're just not that many. Those are called perfect Pythagorean triangles. But most triangles have radical signs in them on one of the dimensions. So when you get to doing trig, you end up having to do radical signs a lot. Okay? Now, let's do cosine of x. What's that?
Cosine of x is
Ka.
cosine.
Think of a crow. In other words, you want to make sure you don't remember it as co. It's C-A-H. Ka. Sohcahtoa. So the ka stands for what?
Cosine adjacent over hypotenuse.
Okay. So do it step by step. What's the adjacent?
1.
The adjacent, not the opposite. They're never going to be the same.
Okay, so that'd be square root 7.
Now you got it. And what's the hypotenuse?
2 square root 2.
Rationalize that.
Square root 14 over 2 square root 4.
Simplify it. In other words, first of all, any square root multiplied by a square root of the same number is that number. You don't need to do square root of 2 times square root of 2 is square root of 4. You don't need to take that step. You just need to say square root of x times square root of x is x. So it doesn't matter. Square root of 17 times square root of 17, I would not want to say that's the square root of 269 because then I'd need to get my calculator. But I can certainly say that it's 17. Okay.
All right.
So whenever you're multiplying radical by the same number, just it's that number. So the bottom is 4. Now, is that simplified?
Okay. Can we break down square root 14?
Well, notice that it was broken down. We had square root of 7 times square root of 2, and those are prime numbers. So there are not going to be factors of 14 where one of them is a perfect square, and that's what you need to simplify something. In other words, I can simplify square root of 20 because one of its factors is a perfect square number. So square root of 20 becomes 2 root 5. I cannot simplify square root of 10 because the only factors of that are 5 and 2, none of which are perfect squares. So this is simplified, that is not. So it all depends on the number and whether or not you can find a factor that is a perfect square number. Okay, that's a pretty good start to trig. Yeah, and we'll probably you'll probably still be on trig on Thursday. Certainly, if they just gave you that paper as you walked out the door. Let's just look at this paper for a moment before I let you go here. This paper doesn't really say anything different than what I just said. The side opposite the right angle is the hypotenuse. You knew that. The leg that is opposite an angle is called the opposite side. You knew that. And the leg that is adjacent is called the adjacent side. And there's the picture of the right triangle with the adjacent, the opposite, and the hypotenuse. So as all this exercise wants you to do is label H, A, or O for these triangles. They don't even put any numbers on them. In other words, this is O for number 1. That's A, and that's H. So first step is to make sure you can do that, and that's what this page does. The next thing they'll do is put numbers on all these triangles, and then they'll ask you the trig functions of those angles, and you have to come up with the ratio. In other words, we've been doing that today. So, all right, trig's fun. It really is. You need a good memory. Trig is going to involve more memory. Not so much in geometry because your trig only goes for about 4 pages here. But next year and the year after, it's all about memory and understanding those terms so that they don't seem so much like a foreign language. All right, Mark, I will talk to you on Thursday at 4.
Okay.
Okay? Bye-bye.
Sounds good, David.